Do you think you know ancient Greece? Marble columns, wise philosophers, epic battles. But beneath the postcards and textbooks lies something far more unsettling. Secrets that leave archaeologists baffled and physicists questioning everything they thought they knew. Stone wheels that simply shouldn't exist. Computers built 2,000 years before computers were even conceived. Maps depicting lands no one had supposedly discovered. Welcome to the Greece they didn't teach you about, where every answer only breeds 10 new questions. 5 cases, 5 mysteries that refuse to be forgotten. These are 5 unsolved enigmas from ancient Greece that continue to haunt researchers to this day. Number 1. The Antikythera mechanism. Dating from between 150 and 50 years before our era, it was recovered from a Roman shipwreck off the coast of the Greek island of Antikythera in 1901. What divers found defied explanation. A bronze device comprised of 37 interlocking gears. The gear ratios were meticulously calculated to predict eclipses, track planetary movements, and chart the cycle of the Olympic Games with a precision unmatched until the 14th century. The main gear alone boasts 223 teeth. The Metonic cycle gear operates on a 19-year pattern. As you turn a crank, bronze pointers trace the paths of the sun, the moon, and the 5 known planets across a calendar spanning decades. Derek de Sola Price dedicated 20 years to analyzing the fragments. X-ray tomography revealed an inscription referencing the lunar spiral. The gear teeth were smoothed from use, indicating someone regularly operated this machine. While the bronze had corroded into a single mass, the original device was housed in a wooden box, roughly the size of a shoebox. Michael Wright, a mechanical computer expert, built working replicas that function precisely as designed. A mechanical computer performing calculations that baffled Renaissance astronomers. The eclipse prediction dial operates on the Saros cycle, 223 lunar months spanning 18 years, 11 days, and 8 hours. Ancient Babylonian astronomers knew this pattern, but the Antikythera mechanism mechanized it with bronze precision. Turn the crank 54 times, and the eclipse pointer advances exactly 1 position. Mathematical perfection cast in metal. Recent computed tomography scans have revealed hidden inscriptions mentioning Venus and Mars by name. The device tracked the retrograde motion of planets when they appear to change direction against the backdrop of stars. Greek astronomers understood this optical illusion required complex orbital mechanics. The mechanism's gears calculate planetary positions with an accuracy of 1 degree over 4-year cycles. Hipparchus developed trigonometry on roads around 160 years before our era. The Antikythera mechanism incorporates his calculations into a mechanical form. The gear ratios correspond to his astronomical constants. A lunar month equals 29.5 days. A solar year equals 365 and 1/4 days. Theoretical mathematics transformed into practical engineering. The shipwreck dates back to 65 years before our era. Its cargo included marble statues, bronze shields, and luxury glassware destined for Roman collectors. This wasn't some prototype locked away in a workshop. Someone was producing precision instruments for practical use. Cutting the gears required metalworking skills that history claims didn't exist until medieval clockmakers. Bronze processing temperatures exceeded 1,000 degrees Celsius. The hand-forged gears exhibit consistent tooth spacing within 2% deviation. Workshop precision achieved with a hammer and chisel. Who built it? The Greeks had no industrial revolution, no machines, no standardized measurements. Each gear tooth was hand-filed to tolerances measured in fractions of a millimeter. One mistake ruins the entire calculation. The smallest gear has 15 teeth, the largest 223. Calculating gear ratios requires a mathematical understanding of prime numbers, fractional reduction, and astronomical periods spanning centuries. Whoever created this device understood mathematical principles that Europe would take 15 centuries to rediscover. Cicero describes similar devices belonging to Archimedes and Posidonius. Marcus Marcellus sees two bronze spheres during the siege of Syracuse in 212 years before our era. One displayed the positions of the stars, the other demonstrated planetary movements. Ancient sources mention astronomical mechanics as an established technology, not a revolutionary breakthrough. The Antikythera mechanism stands as a surviving example of mass-produced scientific instruments. Accused, judged, silenced. Number 2. The Phaistos Disk. Dating back to 1700 before our era. Unearthed in the Minoan palace of Phaistos on southern Crete by Italian archaeologist Luigi Pernier in 1908. A baked clay disc, 15 5/10 centimeters in diameter, 241 symbols arranged in a spiral to be read from the outside in. 45 distinct pictograms ranging from human heads, fish, and birds to tools and geometric shapes. Each symbol imprinted in wet clay using individual stamps, a technology of movable type predating Gutenberg by 3,000 years. The spiral contains 241 impressions in total, divided into 61 groups of words separated by vertical lines. Side A bears 123 symbols in 31 groups. Side B, 118 symbols in 30 groups. Statistical analysis reveals that the frequency of symbols mirrors natural language patterns. Common symbols appear more often, rare ones cluster in specific positions. This is no random decoration, but structured communication. Analysis of the symbols reveals linguistic sophistication. The feathered head appears 29 times, the most frequent symbol, suggesting a common word like underscore, quote, underscore, one, underscore, or underscore, quote, underscore, two, underscore. The shield occurs 19 times, always at the beginning of words, indicating a grammatical marker. The walking man symbol appears 13 times in specific contexts, hinting at verb forms. Computational linguistics identifies a sentence structure, subject, verb, object, aligning with Indo-European language families. John Chadwick applied cryptoanalytic techniques used on Linear B. The letter frequency distribution displays features of an inflectional language with case endings and verb conjugations. Vowel to consonant ratios correspond to ancient Greek and Anatolian languages. The disk contains approximately 200 words of connected prose, not isolated word lists or ritual formulas. Microscopic analysis reveals secrets of its production. Each stamp created identical impressions with consistent pressure depth. Bronze matrices showed wear marks from repeated use. The stamping sequence proceeds from left to right, with systematic spacing between word groups. Quality control demanded masterful craftsmanship. No smudged impressions, no overlapping stamps, no signs of correction. Recent neutron activation analysis confirms the clay originated from the Massara Plain in central Crete. Local pottery workshops operated in this location during the Middle Minoan period. The chemical signature matches clay samples from nearby Minoan sites, dating from 1700 to 1500 years before our era. The disc represents local production, not an imported exotic artifact. Michael Ventris deciphered Linear B in 1952, identifying place names and administrative terms. Arthur Evans deciphered fragments of Linear A using bilingual inscriptions from Hagia Triada. Alice Kober developed a syllabic grid system that revealed grammatical patterns in unknown scripts. Dozens of linguists have attacked the disk using identical methods. Every attempt has failed. The set of symbols appears nowhere else in the archaeological record. Minoan sites across Crete have yielded thousands of Linear A tablets, hieroglyphic seals, and painted inscriptions. None contain the Phaistos disk's symbols. No practice texts, no fragmentary examples, no developmental stages leading to its final form. The disk stands alone. A unique writing system, devoid of archaeological context. Statistical analysis by Gareth Owens identified recurring symbol combinations, suggesting grammatical particles and phonetic values. Computer modeling tested thousands of possible decipherments against known ancient languages. Indo-European, Semitic, and Anatolian language families all produced plausible partial translations. None achieved full coherence across the entire text. The stamping technology poses just as many riddles. Each pictogram required an individual bronze or wooden matrix carved in reverse. 45 different stamps demanded a significant investment in tool production. The matrices show wear from heavy use, suggesting mass production of texts using movable type. Yet the archaeological evidence reveals no comparable printing technology until Chinese block printing in the 6th century of our era, and Gutenberg's innovation in 1460. Quality control demanded systematic approaches. Uniform spacing required measurement standards. Consistent impression depth required pressure regulation. Symbol alignment followed geometric guidelines, invisible in the final product. Someone organized text production on an industrial scale, using standardized procedures that did not reappear until medieval scriptoria. The disk resides in the Archaeological Museum of Heraklion, its 45 symbols guarding their secrets. Linear A tablets from the same period remain partially deciphered, thanks to comparative analysis with Linear B. Cretan hieroglyphs yield partial translations, using Egyptian and Anatolian analogies. The Phaistos disk remains silent to every cryptoanalytic assault. Cold clay, a mystery. Number 3. The geological enigma of the Delphic Oracle. From the 6th century before our era to the 1st century of our era, the ancient world's most celebrated oracle operated from a temple complex erected upon unique geological formations in central Greece. Ancient texts describe the Pythia entering trance states, delivering prophecies while seated on a tripod above a chasm, a fissure releasing vapors. But what fueled these visions? Modern geology is now revealing why this location, for 15 centuries, produced documented altered states of consciousness. In 1998, Jelle de Boer and John Hale investigated the site. Ground-penetrating radar mapped a line of faults directly beneath the temple's foundations. Two major fault systems intersect precisely where ancient accounts place the sacred tripod. The Kurna fault runs east to west. The Delphi fault runs north to south. But what secrets do these faults conceal? Tectonic stress along these fractures releases gases from deep limestone formations. Gas chromatography identified ethylene, methane, and hydrogen sulfide seeping from cracks in the temple floor. Ethylene induces euphoria and dissociative trance states at concentrations measured on site. Ancient sources describe sweet-smelling vapors that triggered prophetic visions. Ethylene possesses a sweet odor, and produces precisely these neurological effects. Could geology have created a natural anesthetic chamber? Bituminous limestone formations beneath Delphi contain hydrocarbon deposits formed over millions of years. Tectonic pressure along the fault intersections forces these compounds upward through fractured rock. Ethylene concentration peaks during seismic activity, when fault movement increases the rate of gas release. The ancient Greeks scheduled important consultations during periods of geological instability, when vapor emissions reached maximum potency. But here, science encounters a wall. Oracle sessions occurred on fixed schedules linked to Apollo's sacred calendar. The Pythia delivered coherent, often enigmatic answers to specific political and military questions. Historical records show her prophecies influenced major decisions throughout the Mediterranean world. Leaders from Croesus of Lydia to Roman emperors consulted Delphi before critical campaigns. Plutarch served as a priest at Delphi around 100 years of our era. He documented the oracle's procedures during 40 years of service. The Pythia purified herself in the Castalian spring, chewed laurel leaves, and drank water from the sacred Cassotus spring before each session. These preparations occurred on the 7th day of each month during Apollo's presence, 8 months a year, with a 4-month winter closure when the god journeyed to the Hyperboreans. Temperature monitoring reveals that fault gas emissions correlate precisely with the ancient religious calendar. Peak ethylene release occurs in late spring and early autumn, exactly when historical sources record maximum oracle activity. The correlation spans 8 centuries of documented consultation records preserved in temple archives and cited by historians from Herodotus to Pausanias. How could random releases of geological gases produce politically relevant information? Modern medical studies show that ethylene exposure causes memory loss, spatial disorientation, and loss of motor control at concentrations measured in the temple chamber. Individuals exposed to similar doses in laboratory settings babble incoherently or lose consciousness entirely. Yet the Pythia maintained sufficient cognitive function to process complex diplomatic questions and formulate responses that often proved strategically accurate. Archaeological evidence reveals a sophisticated underground chamber system directing gas flow beneath the temple. Stone channels carved into the rock channeled vapors toward the tripod site. Bronze fittings regulated flow rates. Fragments of lead pipes indicate precise metalwork designed to concentrate gas emissions in specific locations. Ancient engineers understood fluid dynamics well enough to create a controlled delivery system for naturally occurring psychoactive compounds. Herodotus recorded specific prophecies with verifiable historical outcomes. The oracle advised the Athenians to trust their wooden walls before the Battle of Salamis. Themistocles interpreted this as a naval strategy, leading to a decisive Greek victory in 480 before our era. She warned Croesus that attacking Persia would destroy a great empire. His own fell to Cyrus in 546 before our era. Political accuracy suggests information-gathering networks, not random chemical inspiration. Recent soil analysis identified unusual mineral deposits around the temple foundations. Rare earth elements appear in concentrations found only in active geological vents. Lead isotope ratios match deep limestone formations, confirming the gas's origin from subterranean sources. The sacred site sits precisely at a geological intersection, creating optimal conditions for hydrocarbon emissions. Pausanias described his visit to Delphi in the 2nd century of our era. He witnessed the sacred chasm beneath the temple and observed gas emissions strong enough to extinguish torches. Roman engineers built ventilation systems to manage toxic buildup. Temperature readings from the fault intersection show peak gas release occurs precisely when ancient sources record peak aurical activity. The correlation spans 8 centuries of documented consultations. Modern individuals exposed to ethylene concentrations matching ancient measurements experience euphoria, followed by memory lapses lasting several hours. The Pythia delivered coherent prophecies, remembered complex questions, and maintained awareness throughout sessions lasting up to 6 hours. Did the ancient Greeks possess a higher physiological tolerance for psychoactive compounds? Or did the oracle's procedures involve methods of managing chemical exposure that modern science cannot yet identify? Oracle consultation fees generated enormous revenue for Delphi. Cities paid offerings of gold and silver, worth millions in today's currency. The Siphnian treasury held wealth equivalent to modern state budgets. Economic incentives demanded consistent performance throughout centuries of operation. Random, drug-induced babbling could not sustain such a vast commercial enterprise. The oracle provided value that justified massive investment from across the ancient world. Geology, chemistry, impossibility. Number C. The impossible optics of the Lycurgus cup. Picture this: a Roman artisan in the 4th century of our era crafting a glass chalice. This wasn't just any drinking vessel. It depicted King Lycurgus ensnared in a vine, a divine punishment for defying Dionysus. This artifact, now housed in the British Museum, appears as ordinary green glass under normal light. But illuminate it from behind, and it transforms into a radiant ruby-red transparency. This color-shifting glass baffled material scientists for centuries, until in 1990, electron microscopy revealed its secret: nanoparticles. Embedded within the glass matrix are colloidal particles of gold and silver, measuring a mere 50 to 100 nanometers. As light passes through, these particles scatter specific wavelengths while allowing others to pass through unimpeded. Green light reflects off the surface, while red light penetrates, emerging on the opposite side. This optical effect demands precise control over the size and distribution of these particles, a feat of what we would now call nanotechnology, achieved with the rudimentary tools of the 1st century. A team led by Ganga Logan Liu at the University of Illinois analyzed fragments of the glass using transmission electron microscopy. Their findings? A concentration of just 0.5% by weight of these nanoparticles uniformly dispersed throughout the glass matrix. Higher concentrations would obliterate the effect, creating excessive scattering. Lower concentrations would fail to produce the color change, as too few particles would interact with the light's wavelengths. How did Roman artisans achieve this optimal concentration? Through mathematical calculations, or through generations of systematic experimentation? The dichroic effect itself arises from surface plasmon resonance, the electrons within the metallic nanoparticles oscillating at frequencies corresponding to specific wavelengths of light. Gold particles absorb blue and green light, transmitting red and yellow. Silver particles amplify the scattering effect across the visible spectrum. This combination creates a jade-green reflection and a ruby-red transmission, altering the chalice's appearance depending on the viewing angle and the direction of illumination. Remarkably, modern fiber optic technology employs identical principles for wavelength division multiplexing in telecommunication systems. Roman glassmakers discovered surface plasmon resonance 15 centuries before physicists understood the underlying quantum mechanics. These ancient artisans manipulated the behavior of electrons in metallic nanostructures without any knowledge of atomic theory or electromagnetic radiation. And the production process presents just as many mysteries. The gold and silver particles form as the glass cools through carefully controlled heating cycles and atmospheric conditions. Temperature fluctuations of just 50 degrees Celsius can alter the particle size distribution, destroying the optical effect. Modern furnaces utilize computer-controlled thermostats, maintaining temperatures within a mere 5 degrees. How did the Romans achieve such precision? The secrets of the Lycurgus cup remain, a testament to ingenuity lost to time. Ancient furnaces relied on ingenious fuel management and precise draft control to achieve astonishing levels of precision. Archaeological evidence unearthed from glassmaking workshops in Aquileia and Cologne reveals that Roman furnaces reached temperatures exceeding 1,200 degrees Celsius, fueled by charcoal and sophisticated bellows systems. Calculations of fuel consumption indicate heating cycles that stretched for 12 to 16 hours, demanding constant temperature monitoring. Within the workshop remains, archaeologists have discovered bronze pyrometric cones, ingenious temperature indicators that melted at specific heat levels, providing ancient artisans with a form of precise thermometry. Consider the Lycurgus cup, a chalice standing 14 centimeters tall, its walls varying in thickness from 3 to 7 millimeters. The thicker sections exhibit a deeper red transmission, while the thinner areas appear strikingly brighter. The craftsman meticulously calculated the wall thickness to optimize light transmission, all while maintaining the vessel's structural integrity. Mathematical analysis reveals that the variation in thickness follows logarithmic curves, maximizing the optical effect across the entire surface. Only 12 examples of Roman dichroic glass have survived worldwide. The Lycurgus cup represents the most complete and exquisite known specimen, boasting the fullest preservation of its nanoparticle distribution. Similar fragments have surfaced at villa sites in Pompeii, hinting at a luxury market for color-changing glass among wealthy Roman collectors. Its production demanded specialized knowledge, expensive materials, and an extended fabrication time. Pliny the Elder, the Roman author, mentioned artisans capable of making glass appear in different colors depending on the lighting conditions. His Natural History describes workshops near Mount Vesuvius, producing vessels that seem to magically change their appearance. Archaeological excavations at these sites have indeed uncovered furnace remains and glass fragments exhibiting dichroic properties. Ancient sources confirm that this technology existed as a well-established craft technique, not a mere accidental discovery. Chemical analysis reveals an additional layer of complexity. Trace amounts of copper and antimony subtly modify the optical properties of the glass. Copper enhances the transmission of red light, while antimony amplifies the reflection of green. Achieving the precise chemical composition required, adding these elements at specific stages of the glass-forming process. Too early, and they would burn off. Too late, and they wouldn't distribute evenly. Ancient recipes demanded an exacting sense of timing, relying on visual cues and temperature estimation. Intriguingly, medieval glassmakers, despite having access to Roman workshops and damaged examples, failed to replicate the effect. 10th century Islamic treatises on glass describe attempts to recreate color-changing vessels using gold foil and silver powder. All attempts fell short of achieving true dichroic properties. The knowledge, it seems, was lost with the decline of Roman technical education systems. Venetian masters rediscovered dichroic principles during the Renaissance, employing different methods involving oil-based metal suspensions applied to glass surfaces. Their techniques created similar visual effects, but they lacked the internal nanoparticle structure of the Roman examples. Modern reproduction requires electron beam lithography or laser ablation to achieve comparable particle control within the glass matrix. The British Museum showcases the Lycurgus cup under carefully controlled LED lighting that demonstrates both optical states. Museum conservators alternate the lighting every 30 minutes to prevent photo degradation of the ancient glass. Visitors witness an ordinary jade green chalice transform into a glowing ruby red transparency. 4 centuries of Roman engineering condensed into 40 seconds of impossible beauty. Reflection, transmission, seemingly impossible. Number 5. The acoustic secrets of the Labyrinth of Knossos. 1500 years before our era, Sir Arthur Evans began excavating the Minoan Palace complex. The now famous labyrinth sprawls across 8 acres, boasting 1,400 rooms connected by corridors, stairwells, and courtyards, arranged in seemingly random patterns. But modern acoustic analysis reveals something extraordinary. The labyrinth functioned as a sophisticated sound management system, employing principles that challenge our understanding of ancient architecture. In 2015, Jeg Reznikov meticulously mapped the acoustic properties throughout the palace complex using precision sound measurement equipment. What he discovered was astonishing. Sound waves behaved uniquely in each section of the labyrinth. Consider the throne room. It amplifies whispered conversations near the carved stone chair, while simultaneously filtering out external noise from the adjacent courtyards. Acoustic modeling demonstrates that the chamber's design creates standing wave patterns, focusing sound energy directly toward the throne's position. Some corridors act as echo chambers, transmitting voices across vast distances. The processional corridor, stretching 87 meters, features limestone walls precisely angled to guide sound waves. A person speaking in a normal voice near the southern entrance can be heard clearly at the northern exit, despite 3 changes in direction and 2 changes in elevation. This remarkable sound transmission is achieved through calculated reflection angles built into the wall surfaces. Yet other passages completely suppress sound, creating zones of absolute silence just meters away from areas of high transmission. The Queen's Megaron, for example, sits adjacent to a noisy central courtyard, but remains acoustically isolated thanks to a double wall construction with air gaps that absorb vibrations. Measurements of wall thickness reveal systematic variations designed to control sound transmission, not simply to provide structural support. The central courtyard measures 52 by 28 meters, dimensions that create standing wave patterns at specific frequencies when crowds gather. Acoustic analysis reveals that the space resonates at 440 Hz, a musical note just above middle C. When filled with people, their collective voices naturally harmonize at this frequency, thanks to the architectural amplification. The Bronze Age Minoans built an amphitheater tuned to human vocal harmony 15 centuries before Greek theaters incorporated acoustic design principles. But the surprises don't end there. Underground chambers beneath the main palace exhibit even stranger properties. The so-called Snake Goddess Sanctuary amplifies sounds originating from the courtyard above, while remaining impervious to noises from adjacent underground rooms. Acoustic modeling suggests that this effect requires precise chamber dimensions and doorway positioning, calculated using advanced mathematical principles. The room measures 12 by 8 meters, with a ceiling height of 4 meters, proportions that create selective frequency filtering. Sound transmission tests using modern equipment confirm this ancient acoustic engineering. Low-frequency sounds, below 200 Hz, travel freely throughout the complex, thanks to the stone construction that conducts vibrations. Mid-frequency sounds, between 200 and 800 Hz, follow predetermined paths dictated by the corridor design. And high-frequency sounds, above 800 Hz, remain localized due to calculated absorption by specific wall materials and surface textures. Analysis of the wall construction reveals systematic acoustic design throughout the complex. Load-bearing requirements would dictate uniform thickness, but measurements show walls ranging from 30 centimeters to 2 meters thick with no structural justification. Thick walls absorb sound through mass, while thin walls transmit vibrations. This pattern of thicknesses creates acoustic zones that guide sound along predetermined paths while blocking transmission in other directions. Modern concert halls use computer modeling and advanced materials to achieve comparable acoustic control. Carnegie Hall, for instance, employs scientifically calculated dimensions, surface angles, and absorbent materials to optimize sound quality. The Minoan Palace complex achieved similar results using Bronze Age technology and geometric knowledge. Three-dimensional acoustic engineering executed with stone blocks and bronze tools. Linear A tablets from Gnosis contain references to, quote, 3 and, quote, 4, according to partial translations by archaeologist Gareth Owens. Administrative records mention officials responsible for quote, 5, and regulations governing sound pathways throughout the palace. The labyrinth wasn't built to confuse visitors. It was designed to control their auditory experience through calculated manipulation of architectural acoustics. Religious ceremonies took place in acoustically optimized spaces designed for their specific functions. The lustral basin chamber amplifies chanting through calculated reverberation times. Ritual processions followed routes that enhanced footsteps and ceremonial music. Administrative meetings occurred in rooms that prevented eavesdropping, while enabling clear internal communication. Royal audiences took place in spaces that amplified the ruler's voice, while masking conversations among courtiers. Recent excavations have revealed additional acoustic features. Stone-lined channels beneath floor level transmit sound between rooms without any visible connection. Bronze fittings show evidence of mechanical sound amplifying devices, perhaps foot-operated, that enhanced voice transmission over long distances. Minoan engineers integrated acoustic infrastructure into the palace's very structure, much like modern buildings incorporate electrical and plumbing systems. Experimental archaeology, using full-scale reconstructions, confirms these acoustic properties. Teams from Oxford and Cambridge have built partial replicas of the palace, using original construction techniques. The sound behavior matches both the computer models and the ancient acoustic achievements. The Bronze Age Minoans understood wave mechanics, frequency resonance, and architectural acoustics at levels comparable to modern engineering schools. Whispers, echoes, silence. What secrets will the Labyrinth of Knossos reveal next? If you appreciate such well-documented work, let us know in the comments from which city you are listening. 5 enigmas, 5 challenges to everything historians believe about ancient capabilities. The Antikythera mechanism proves that Bronze Age Greeks mastered precision engineering. The Phaistos disk demonstrates movable type printing 3 millennia earlier than previously thought. Delphi reveals geological knowledge bordering on modern chemistry. The Lycurgus cup showcases nanotechnology crafted with ancient tools. Knossos exhibits acoustic architecture rivaling computer-designed concert halls. Each discovery forces uncomfortable questions about technological timelines and the transfer of knowledge. Did the ancient Greeks independently develop these abilities, or did they inherit them from more advanced predecessors? Why do these technologies appear in isolation without clear developmental progression? How much knowledge vanished during transitional periods in history? Recent excavations at Akrotiri on Santorini have unearthed Bronze Age frescoes depicting landscapes from civilizations that, according to conventional chronology, should not have existed. Ground-penetrating radar studies in Knossos reveal additional subterranean chambers still sealed after 4,000 years. Marine archaeology continues to recover impossible artifacts from Mediterranean shipwrecks dating back centuries before their supposed invention. But the greatest mystery lies not in individual artifacts, but in their systematic disappearance. Advanced technologies flourished, then vanished without explanation. Knowledge that took millennia to redevelop suggests either catastrophic loss events or deliberate suppression. The archaeological record reveals gaps where sophisticated abilities simply cease to appear in the material culture. Imagine this. In 2019, construction workers expanding the Athens metro system stumbled upon an unmarked chamber 17 meters below modern street level. Initial investigations revealed Bronze Age pottery mixed with Roman coins and Byzantine jewelry, spanning 2,000 years of continuous deposition. At the chamber's base, archaeologists unearthed a stone tablet covered in symbols that match no known ancient script. The chamber walls exhibit tool marks consistent with precision cutting techniques found at other mysterious Greek sites. Carbon dating indicates construction around 1,300 years before the Common Era, the very peak of the Bronze Age collapse, when advanced civilizations across the Mediterranean simultaneously crumbled. The tablet remains untranslated. 5 ancient mysteries become 6.